I want to be talking about the product rule and the quotient rule. I don't know, it's about quotient, it's whatever. Anyways, so if I have two functions, f at x, or sorry, we could call these compositions of a different function times g at x, and we want to take the derivative of this function in terms of x, this would equal to f prime times g plus g prime times f. Or it's the derivative of the first function multiplied by the normal of the second function plus the derivative of the second function times just the standard first function. So I'll do an example. Let's say f at x equals to 3x squared plus 2 times x minus 4. Now we could expand this and use the power rule, but let's try and use the product rule here. So I'll give these two functions names, or these two brackets names. I'll call this u and I'll call this v. So the product rule tells us that d of dx of f equals to u prime times v plus v prime times u. So what is u prime, right? So let's just substitute this in. So u prime would be, I will use a different color here, will be the derivative of 3x squared plus 2 multiplied by v, x minus 4. I'll use a different color here, x minus 4. And I added with the derivative of v, so I'll write that down, x minus 4 prime, multiply that by u, which is 3x squared plus 2. And when we evaluate this, what is the derivative of 3x squared plus 2? Well, that's just 6x, right? And then the derivative of 2 here is 0, so this is just 6x times x minus 4. And then we add this with the derivative of this, which is 1 times 3x squared plus 2. Now, when we expand this, this will become 6x squared minus 24x plus 3x squared plus 2. And this would equal to 9x squared minus 24x plus 2. Now, we can actually verify this if you expand this, right? So let's go back to what we did previously. So let's erase all this except for the final answer, and let's just expand this and use the power rule, right? We go back to our elementary, or sorry, our like basic sort of ways. So when we do expand this, 3x squared times x is equal to 3x cubed, and then 3x squared times negative 4 would be negative 12x squared plus 2x minus 8. So when we take the derivative of this, f at x, this would equal to 9x squared minus 24x plus 2. And we notice that these two are the exact same. However, you can't always expand it because it might be a much more uglier function, or it might be a function involving trigonometry and or trigonometric functions or logarithms or some sort, and in the end you can't really expand that and use the power rule. So this is where the product rule comes in place. Now, what about the inverse of multiplication? What about division? What if I have two functions dividing each other, right? So let's just use an example here. So let's say f at x equals to x squared plus 2 divided by 4x. Now you could just distribute that 4x to the x squared to the 2, and you could use the power rule, but let's use something called the quotient rule. Now what the quotient rule is if I have, if f at x equals to, let's say u of x divided by v at x, then f prime at x would equal to u prime times v minus v prime times u divided by v squared. And you could actually solve this using chain rule and product rule, but I'm not going to go through that. So let's just use this formula here and apply it onto this. So I'm going to move this over here. Give me a second. Like so. And then let's use this formula. So what is our u? Our u is going to be x squared plus 2. And our v is going to be equal to 4x. So u prime times v is what? So what is u prime? U prime would equal to 2x, and then v prime would equal to 4. Let me just substitute it in. So u prime will be 2x. So sorry, let me write this more clearly. So f prime and x would equal to u prime times v minus v prime times u divided by v squared. And then if we just substitute it in, here, let me erase this so we have a bit of extra space. We just substitute everything in, we have 2x times 4 minus 4 times x squared. Or sorry. This is actually 4x. 4x and then 4 times x squared plus 2 divided by v squared. And then what is v squared? That is going to be 4x squared. And if you expand this, this would equal to 8x squared minus 4x squared minus 8 over 16x squared. And this would equal to 4x squared minus 8 over 16x squared. And in this, you could divide both top and bottom by 4. So it'll be x squared minus 2 over 4x squared. And that's your final answer.